In this lecture we'll find out the length of line segment X. In the drawing we have a quarter circle. Inside AOB is a quarter circle. Inside this quarter circle we have a semicircle. OB is a semicircle. And we also know that line segment AO equals to 10 units in its length. And our mission is to find out the length of this line segment AM, that's equal to X. We have to find out the value of X that's equal to AM. Okay, so first of all we know that AOB is a quarter circle, therefore this angle AOB is a right angle. It is equal to 90 degrees in its size. In addition, because of the fact that AOB is a quarter circle, AO and OB, they are both the radii of this quarter circle. But we know that AO equals to 10, therefore OB, that is also the radius of this quarter circle, must be also equal to 10 units in its length. OB equals to 10. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So we know that the diameter OB of this semicircle equals to 10 units. Therefore the radius must be equal to 10 over 2, that is 5. So the radius of this semicircle equals to 5 units in its length. We define the center of this semicircle as P. So OP is the radius of this semicircle that is equal to 5 units in its length. PV is also the radius of this semicircle, therefore it is equal to 5 units. We define the point of tendency of tangent AM with this semicircle as Q. In the next step, we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, therefore it is equal to 5 units. The radius PQ of this semicircle is drawn to point Q, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. In the next step, we'll focus at this point, point A. Point A is an external point in relation to this semicircle, because it is not located inside this semicircle, nor on the semicircle, but it is located outside this semicircle, therefore it is an external point in relation to this semicircle. From point A, we have two tangents to this semicircle, tangent AO and tangent AQ. Or tangent AM, that is actually tangent to on this semicircle point Q. So we have two tangents, tangent AO and tangent AQ. And according to rule number 2, the lengths of two tangents from a common external point to a circle are equal. From the common external point A, we have tangent AO and tangent AQ, and according to rule number 2, they are equal to each other. But AO equals to 10, therefore AQ must be also equal to 10, because they are equal to each other. So AO equals to 10 units in its length. In the next step, we'll extend line segment AM and line segment OB by a straight line until they touch each other. And we define the touching point of the extended AM and OB as N. By doing this construction, we actually created the big triangle AON. We define this angle ONA as theta, and we'll continue to focus on the right big triangle AON. On the right big triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we will focus on the green right small triangle QPN. In the right big triangle, right green triangle QNP, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. In order to complete the sum of the angles in this green right triangle QPN to 180 degrees, the missing angle must be equal to 90 degrees minus theta. In the next step, we'll prove that the right big triangle AON is similar to the right small green triangle QPN. So write it down. The right big triangle AON is similar to the small green right triangle QPN. Again, we prove that the big right triangle AON is similar to the small green triangle right triangle QPN. So, why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So this is angle AON in the big triangle. And it is equal to this angle, that is actually angle PQN in the small green right triangle, PQN. Repeat again. Angle AON in the big right triangle is equal to angle PQN in the small green right triangle. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. It is a common angle that belongs to both triangles, therefore we can write down that angle theta equals to itself. If we relate to angle theta as it belongs to the big right triangle, it will be defined as angle ANO. And if we relate to this angle theta as it belongs to the green triangle, it will be defined as angle QNP. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta is a common angle that belongs to both angles. It is equal to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle OAN in the big triangle. and it is equal to this angle in the in the green triangle, that's actually angle QPN. Repeat again. Angle OAN in the big triangle is equal to angle QPN in the small green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, we actually proved that all the three angles of the big right triangles AON are correspondingly equal to all the three angles in the small green right triangle QPN. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I write it down. The big right triangle AON is similar. This is the sign of similar to the small green right triangle QPN according to angle similarity rule. And from the fact that triangle AON is similar to triangle QPN, we will derive that the following relationship exists between their sides. That AO in the big triangle AON, AO, side AO over side QP in the small green triangle is equals to AN in the big side AN in the big triangle over side PN in the small green triangle, and it is also equals to side ON in the big triangle over side QN in the green small triangle. So actually we found out that AO over QP equals to AN over PN equals to QN equals to ON over QN. AO is 10 over QP. QP is 5, and it is equal to AN. What is the length of AN? AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10 plus QN. So in total, AN equals to 10 plus QN. Over PN. What is the length of PN? PN equals to PB plus BN. That is to say, PN equals to PB, that is 5 plus BN. So in total, PN equals to 5 plus BN. PN equals to 5 plus BN. And it is equals to ON. What is the length of ON? ON in total equals to 5 plus 5 plus Bn. Again, On equals to 5 plus 5 plus Bn. So in total, On equals to 10 plus Bn. On equals to 10 plus Bn. over Qn. Qn is the missing side, so we leave it as it is. Here 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, and it is equals to 10 plus Bn over Qn. So those two sides are equal to each other. So we create equation number 1 from those two sides that are equal to each other. So according to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two sides are also equal to each other. Therefore, we can create from those two sides equation number 2. So according to equation number 2, 2 equals to 10 plus Bn over Qn. So here we multiply this equation number 1 by 5 plus Bn. And we get that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. Repeat again. According to equation number 1, I actually found out that 2 times 5 plus Bn equals to 10 plus Qn. Here we will open the brackets on this side of equation number 1. So 2 times 5 is 10 plus 2 times Bn is 2Bn. That is equal to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 will get cancelled and we left only with Qn, that is equals to 2 times Bn. And again, according to equation number 1, Qn equals to 2 times Bn. According to equation number 2, we found out that 2 equals to 10 plus Bn over Qn. Here we multiply this equation number 2 by Qn, and we get that according to this equation number 2, two times Qn equals to 10 plus Bn. Okay. Now we can substitute Qn in this equation number 2 by 2 times Bn. Because Qn equals to 2 times Bn. We do it now and we get that 2 times Qn, and Qn is 2 times Bn. That is equal to 10 plus Bn. So in this side of equation number 2 we have 2 times 2Bn is 4Bn. So 4Bn equals to 10 plus Bn. 4Bn equals to 10 plus Bn. Here we subtract Bn from this equation equation number 2. And we get that according to this equation number 2, 4bn plus bn is 3bn. So 3bn equals to 10. Here we divide this equation number 2 by 3. And we get that according to this equation number 2, bn equals to 10 over 3. So now that bn equals to 10 over 3, so we can write down in the original volume that bn equals to 10 over 3. This 97bn equals to 10 over 3 units in its length. And according to equation number 1, Qn equals to 2 times Bn. And Bn is 10 over 3, so Qn equals to 2 times Bn is 10 over 3. So in total Qn equals to 2 times 10 over 3. 2 times 2 is 20, so in total this expression equals to 20 over 3. So in conclusion we found out that Qn equals to 20 over 3. Qn equals to 20 over 3. It is twice as large as Bn. Or twice as long as Bn. Qn, this nice element Qn is equals to 20 over 3 units in its length. Okay. In the next step, we'll complete this quarter circle to a circle. So we completed the quarter circle to a circle. And again, we completed this quarter circle to a circle. And we'll extend side BO by straight line until it touches the circle. And we define the touching point of the extended side BO with this circle as C. In the next step, I'll present to you a new rule and we will implement the new rule in our drawing. The new rule is rule number 14. According to rule number 14, rule number 14 is true in any circle. So in any circle, if you draw two chords A, B and C, D inside the circle from the common external point, point P, then the following equation will be true, that PA times PB equals to PC times PD. So we have here this circle and the common external point, point P. From the common external point, point P, we draw two chords inside this circle, chord AB and chord CD. So in this drawing, the following equation will be true. That PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So whenever you draw from a convex standpoint two chords inside the circle, then this equation will be true. Okay, so we can actually implement rule number 14 in our drawing. Why? Because in our drawing we have the common standpoint point N. From the common standpoint point N, we have here two chords that are drawn inside this circle, chord BC and chord MA. Again, from the common standpoint N, we have two chords inside this circle, chord BC, and the second chord is called AM or MA. So actually all the requirements of rule number 14 are met, therefore we can implement rule number 14 in our drawing. Okay. So here we relate to the common standpoint point N. And because of the fact that from the common standpoint point N, we have actually two chords inside the circle, chord BC and chord MN. We can implement rule number 14. According to rule number 14, NB times NC equals to NM times NA. Repeat again. According to rule number 14 in our original drawing, NB times NC equals to NM times NA. Okay. Again, here we have to find out the length of this line segment NM. Okay. So what is the length of NM? From the drawing, it is very easy to see that NM equals to QN minus QM. QN minus QM. I'll repeat again. The length of this line segment MN or NM equals to QN minus QM. Again, NM equals to QN minus QM. QN equals to 20 over 3 minus QM. Again, NM equals to QN, that is 20 over 3 minus QM. So write it down. The length of this line segment MN equals to 20 over 3 minus QM. Okay. Now we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. So NB, what is the length of NB? NB equals to 10 over 3. Repeat again, NB equals to 10 over 3 times NC. NC, what is the length of NC? NC in total. First of all, what is the length of line 7CO? Point O is the center of the circle, point C is the point of the circle itself, therefore OC is the radius of the circle. The radius of the circle and the radius of the quarter circle are the same, and the radius of the quarter circle is 10, therefore the radius of the circle CO must be equal to 10. We just completed the quarter circle to a circle, therefore it's very clear that they have the same radius. So CN or NC, CN in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. Again, CN in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So NC in total equals to 20 plus 10 over 3, and it is equals to NM. We just right now found out that NM equals to 20 over 3 minus QM times NM, or times NA. What is the length of NA? NA, this is line 7 NA or AN, this is equal to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. Okay, so here 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to work a common factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total, in the numerator we have 70 divided by 3. And it is equals to, here we have 20 over 3 minus QM. Here we multiply minus QM by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. And we get that minus QM times 3 is minus 3 QM. So in total, in the numerator we have 20 minus 3 QM over 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total, in the numerator we have 50 divided by 3. So here on both sides of this equation we have in the denominator 3 times 3, that is 9. Therefore we will multiply this equation by 9 in order to eliminate the denominator 9. We multiply it by 9 and we get that according to this equation, after we cancel the denominator on both sides of the equation, we left only this side of the equation, we left only with 10 times 70. This is equal to 20 minus 3 QM over 3 times 50. We have already eliminated 3, so it is 20 minus 3 qm times 50. Here we divide this equation by 9, and we get that 10 over 10 is 1, so here we have to leave 70 on this side of the equation. That is equals to 20 minus 3 qm times 50, and 50 over 10 is 5. So here we'll open the brackets on this side of the equation, and we get that 70 equals to 20 times 5 is 100, and minus 3 qm times 5 is minus 15 qm. Here we subtract from this equation 70, and we get that 70 minus 70 is 0, so, and 100 minus 70 is 30, so 30 minus 15 qm equals to 0. Here we add 15 qm to this equation, and we get that 30 equals to 15 qm. Here we divide this equation by 15, and finally we get that qm equals to 30 over 15, that is 2. So qm equals to 2 units in its length. So here we have this line segment qm equals to 2 units in its length. Our mission is to find out the length of line segment AM, that is x. So x equals to AM, and from the drawing it is very easy to see that AM in total equals to AQ plus QM. AM equals to AQ plus QM. That is to say, AM equals to AQ, that is 10, plus QM. We just right now found out that QM equals to 2, so it is 10 plus 2. So in total, x equals to AM equals to 10 plus 2, that is 12. So x equals to AM, that equals to 12 units in its length. And that is the answer to the question. I'll put again. Line segment AM is equal to x, it is equals to 12 units in its length. So in the next step, I will summarize the lecture. In this lecture, I found out the length of this line segment AM is equal to x. So in the drawing we have a quarter circle, AOB is a quarter circle. Inside this quarter circle AOB we have this semicircle. OB is a semicircle. And we also know that line segment AO equals to 10 units in its length. Again, our mission is to find out the length of this line segment AM, that is equal to x. So here, first of all, we know that AOB is a quarter circle, this is a quarter circle, and therefore this angle AOB must be equal to 90 degrees. This is the first thing. In addition, AO must be equal to OB. They are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore OB, this is also the radius of this quarter circle, must be also equal to 10 units in its length. OB equals to 10. But OB is not only the radius of this quarter circle, but it is also the diameter of this semicircle. So OB is the diameter of the semicircle. We define the center of the semicircle as P. Therefore, the radius OP of this semicircle must be equal to 10 over 2, that is 5. The radius PB is 5 of the semicircle. Then we define the point of tendency of tangent AM with this semicircle as Q. And then we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of this semicircle, that is equal to 5. Okay, then the radius PQ is drawn to the point of tendency. That is to say, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever your radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees, and this angle equals to 90 degrees according to rule number 1. Then we focused on point A. Point A is an external point in relation to this semicircle, and from the common external point A, we have two tangents to this semicircle. Tangent to this semicircle, tangent AO and tangent AQ. According to rule number 2, they must be equal to each other. The lengths of two tangents from a common external point to a circle are equal. Therefore, AO equals to AQ. But AO equals to 10 according to what is given as the equation, then therefore AQ must be also equal to 10. In the next step, we extended line segment AQ, line segment AM, and line segment OB by straight line until they touch each other. We define this touching point as point N. We define the touching point of the two extended AM and QB as N. By doing this construction, we actually created the right big triangle, triangle AON. We define this angle ANO as theta. Then we continue to focus on the right triangle AON. This angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, this equals to 180 degrees. That is the sum of the angles in any triangle. Then we focused on the right great triangle, triangle PQN. In the right great triangle PQN, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta, according to the same logic, of course. So, in the next step, we proved that the right big triangle, triangle AON, is similar to the right green triangle, triangle PQN. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, angle theta is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles in the right big triangle, triangle AON, are correspondingly equal to all the three angles in the right small green triangle, PQN. Therefore, we actually proved that the right big triangle AON is similar to the right green triangle PQN according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will conclude that the following relationship exists between their sides. We conclude that side AO in the big triangle AON over side QP in the small triangle PQN equals to side AN in the big triangle over side PN in the small triangle, and it is equal to side ON in the big triangle over side QN in the small triangle. Repeat again. We derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5. What is the length of AN? AN equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN. So in total, AN equals to 10 plus QN. Repeat again, AN equals to 10 plus QN over PN. What is the length of PN? PN in total equals to PB plus BN. That is to say, PN equals to PB, that is 5, plus BN. So in total, PN equals to 5 plus BN. Repeat again, PN equals to 5 plus BN. PN equals to 5 plus BN. And it is equals to ON. What is the length of ON? ON in total equals to 5 plus 5 plus BN. That is to say, ON equals to 5 plus 5, that is 10, plus BN. So in total, ON equals to 10 plus BN. Repeat again. ON equals to 10 plus BN over QN. QN is the missing side, so we leave it as it is. So those two sides are equal to each other. We get the equation number 1 from those two sides that are equal to each other. Here, 10 over 5 is 2. So those two sides are equal to each other. We get the equation number 1 by those two sides that are equal to each other. That is to say, according to equation number 1, 2 equals to 10 plus QN over 5 plus BN. And those two sides are also equal to each other. We get the equation number 2 from those two sides that are equal to each other. That is to say, according to equation number 2, 2 equals to 10 plus Bn over Qn. So those are the two equations. Here we multiply this equation number 1 by 5 plus Bn, and found out that according to equation number 1, 2 times 5 plus Bn equals to 10 plus Qn. So again, according to equation number 1, we actually found out that 2 times 5 plus Bn equals to 10 plus Qn. We open the brackets on this side of this equation number 1, and found out that 2 times 5 is 10, plus 2Bn equals to 10 plus Qn. We have 10 on both sides of the equation, so 10 will get cancelled. We left only with Qn, that is equals to 2 times Bn. So according to equation number 1, Qn equals to 2 times Bn. According to equation number 2, 2 equals to 10 plus Bn over Qn. We multiply this equation number 2 by Qn, and found out that 2 times Qn equals to 10 plus Bn. So 2 times Qn equals to 10 plus Bn according to equation number 2. And we have already found out that Qn according to equation number 1 equals to 2 times Bn. So we can substitute Qn in this equation number 2 by 2 times Bn from equation number 1. We did it, and we got that 2 times Qn is 2 times Bn, that is equals to 10 plus Bn. So here we have 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Again, 4Bn equals to 10 plus Bn. We subtracted Bn from this equation number 2, and found out that 4Bn minus Bn is 3Bn, so 3Bn equals to 10. Then we divided this equation number 2 by 3, and finally found out that Bn equals to 10 over 3. Here, this line segment Bn equals to 10 over 3 units in its length. And we have, according to equation number 1, Qn equals to 2 times Bn. When we just right now found out that Bn equals to 10 over 3. So Qn equals to 2 times Bn, and Bn is 10 over 3. So Qn equals to 2 times 10 over 3. 2 times 10 over 3 is 20 over 3. So in conclusion, found out that Qn equals to 20 over 3 units in its length. This line segment Qn Qn equals to 20 over 3 units in its length. Okay, then we completed this quarter circle to a circle, and we extended side BO by straight line until it touches the circle. We define the touching point of the extended side BO with this circle as C. And then I presented to you rule number 14, and we implemented rule number 14 in our drawing. according to rule number 14, rule number 14 is true in any circle. So if from the common extreme point P you draw two chords inside this inside any circle, here from the common extreme point P we have here chord AB, and from the same common extreme point P we have here chord CD. So whenever you draw two chords from a common extreme point P inside the circle, like in this drawing, then the following equation will be true. That PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can implement rule number 14 in our drawing. Why? Because in our drawing, from the common extreme point N, we have here two chords inside this circle, chord MA and chord BC. Therefore, all the requirements of rule number 14 are met, and for that reason we can implement here rule number 14. According to rule number 14, NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. And we found out the length of this line segment MN. From the drawing itself, it is very easy to see that MN equals to QN minus QM. Again, QN minus QM equals to MN. Repeat again, MN equals to QN minus QM. So MN equals to QN, that is 20 over 3, minus QM. So in total, MN equals to 20 over 3 minus QM. Here, MN equals to 20 over 3 minus QM. Now we return to rule number 14. According to rule number 14, NB times NC equals to NM times AN. NB is 10 over 3 times NC. Just write down from NC. What is the length of NC? NC in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So in total, NC equals to 20 plus 10 over 3. Here, NC in total equals to 20 plus 10 over 3, and it is equal to MN. We just right now found out that MN equals to 20 over 3 minus QM times AN. What is the length of AN? AN in total equals to AQ plus QN. AQ is 10 and QN is 20 over 3, so in total AN equals to 10 plus 20 over 3. Here, AN equals to 10 plus 20 over 3. So here we have 10 over 3 times 20 plus 10 over 3. Here we multiply 20 by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. So 20 times 3 is 60, and 60 plus 10 is 70. So in total in the numerator we have 70 divided by 3, and it is equal to 20 over 3 minus QM. Here we multiplied minus QM by 3 and then we divided by 3 in order to have a common factor with 20 over 3. So minus QM times 3 is minus 3QM. So in total in the numerator we have 20 minus 3QM divided by 3 times 10 plus 20 over 3. We multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So 10 times 3 is 30, and 30 times 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So in both sides of the equation, in the denominator we have 3 times 3, that is 9. Therefore we multiply this equation by 9 in order to eliminate the denominator 9. And we left only is the numerator. So we eliminated 9 from the denominator. We left only with 10 times 70. That's equals to 20 minus 3QM times 50. Here we divided this equation by 10. 10 over 10 is 1, so we left this out of the equation only with 70. That's equal to 20 minus 3QM and times 50. And 50 over 10 is 5. So in total we actually found out that 70 equals to 20 minus 3QM times 5. Here we open the brackets on this side of the equation and found out that 70 equals to 20 times 5 is 100, and 5 times minus 3QM is minus 15QM. So in total we found out that 70 equals to 100 minus 15QM. Here we subtract the 70 from this equation and found out that 70 minus 30 is 0 and 100 minus 70 is 30. So 0 equals to 30 minus 15 qm. Here we added 15 qm to this equation and finally found out that 30 equals to 15 qm. Here we divided this equation by 15 and finally found out that qm equals to 2 units. In this line segment qm equals to 2 units in its length. Our mission is to find out the length of this line segment AM. Again, our mission is to find out the length of AM that is equal to x, according to what is given as a question. What is the length of AM? From the drawing it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ is 10 and we just right now found out that QM equals to 2. So in total AQ plus QM is 10 plus 2. 10 plus 2 is 12. So x that is equal to AM, equals to 12 units in its length. Repeat again, the length of this line segment AM that is equal to x, it is equals to 12 units in its length. Okay, thank you very much.